Good morning.
Good morning.
Welcome to Corvalent's webinar on AI and ML as it applies to industrial IoT. I'm your host, Alan Weiss, and I'm here today with some industry experts that I think will have some very interesting information for you. So why don't we introduce them? The first is Gaute Solaas. Would you like to explain who you are?
Yeah, thank you. My name is Gaute Solaas. I am Norwegian by background, hence the name. I have been in data science and I would say high tech since 1997. Started my first firm in New York City back in the 90s, focused on custom engineering solutions, and have never stopped. Now I'm the founder, managing partner of IQumulus here in Austin. And we've been around now for 14 years focusing on data science and machine learning techniques for industry.
Very good. And I'm also here with the CEO, Ed Trevis. Ed has been CEO of this company for how long, Ed? 30 years?
30 plus years, yes. Yes, I've been CEO of Corvalent Corporation, president and CEO and one of the founders. And we have traditionally been in industrial computing technology, so mainly hardware. 5 years ago, we decided to go into software and introduce an IoT platform. And today we have an entire building blocks for an IoT implementation.
Right. So you have not only the enterprise software, the dashboards, the decision-making abilities, but also the sensors, edge computers.
That's correct.
Everything.
Yeah, we actually go from servers to edge computers to gateways to sensors, one-stop shop, basically for a whole IoT implementation. Yeah.
Good. As a reminder to the audience, if you have questions, please write them down in the chat box, and we'll get to them at the end of this little interactive session that we have here. First of all, question for Gaute. How do you define AI in the context of industry?
Very good question. AI is first and foremost a philosophical construct, regardless of industry or context. I think it's important for most people to realize that this is a 3,000-year-old history and saga, where we've always tried to approach the creation of something that is greater than ourselves, right, in a philosophical context, and we keep trying. And so it's more of a philosophical debate. I think what we focus on, and what I've focused on for many years now, is machine learning and machine learning techniques. And machine learning techniques consist of modern mathematical statistics, and those are what power even popular commercial products like ChatGPT at this point.
For our audience, can you sort of comb out what the difference is between AI and ML, between artificial intelligence and machine learning? Isn't it the same thing?
It is in practicality, right? Modern AI is essentially modern machine learning. And so machine learning techniques are a set of families of mathematical statistics techniques that can be applied to a number of different problem areas. And so for all intents and purposes, when we speak of AI, we're really addressing modern machine learning and machine learning techniques.
I'm with you. I'm with you on that. So what's the number one thing you wish industry executives knew about deploying AI and ML? I mean, like in the real world, theory is fine, but it has to improve something, right? How would it change the way you looked at and approached industrial AI and ML?
Very good question. I think there's two things I think corporate executives should study and potentially spend a little more time on than they most likely currently are, right? And the first is the idea that centralization of data is the kind of panacea to all corporate analytics challenges. Meaning there's been a big push over the last 10-15 years, lots of investment spent on centralization of data on the cloud.
You're talking about the cloud, right?
The cloud, and the idea that if we can create a centralized data repository for the entire corporation, we now have the data catalog we need to solve all our problems, right, going forward. I'll come back to it. It's not correct, right? And so there's a need for adjustment here, and that comes back to study and education. So I think that comes back to what I wish an executive would know today. Number two, when it comes to the actual execution, there is no such thing as a static scenario in the real world, right? So in heavy industry, we have a lot of heavy machinery that's very complex, lots of physical processes, it's physics. And when we deal with those types of nonlinear variable processes, off-the-shelf systems provide static models and solutions that are rarely a fit. So in other words, the other main element I think corporate executives should study and learn more about is how off-the-shelf software typically fails over the last 50 years to solve real-world problems that we find in heavy industries. And this all comes back to the fact that at the end of the day, what we're dealing with is science, it's physics, right?
Right.
And so what we need is more of a scientific approach. And so we focus with our clients a lot on the scientific machine learning side of it, applying things like physics-informed neural networks, for example, that are informed by real-world physics. And we do it from the bottom up, right? So we work the problem from the bottom up, from first principles. But I think, to your original question, what I wish most executives knew, I wish they understood some of these basic foundational principles of the application of technology in general.
I want to pick up on something you mentioned also as well, Ed. A lot of people think that the cloud was, as Gaute said, a panacea for everything. We have one large repository of everything in the company. Do you find that the trend now is swinging back to be a little more balanced towards some of the data is in the cloud and some is processed on the edge?
Yeah, absolutely. And I think a lot of companies are relying on the edge. Everything's pretty much going to the edge in many ways. I think one of the points that I wanted to bring up and is talk about data integrity and failure of software. I think one of the things that the integrity of data, it not only relies on the software itself, but the infrastructure of hardware,
right,
and infrastructure of communications, right? And one of the reasons we got into this business is because we wanted to build reliable hardware for a long time, exactly the same, because inconsistencies in design of hardware causes major problems out there, and especially when you talk about data integrity. Data integrity is something that it not only relies on a software, but relies on a hardware as well. So it's one of the reasons we actually a full turnkey house is because we're going from servers to the edge, to the gateways, to the sensors, and making sure that we actually provide these entire building blocks for a customer to do the implementation. Not only we're providing this, but we're actually supporting that in the long term.
So for the oil and gas industry, the subject of this webinar, you can provide what? The software, the edge computers, the servers, the sensors, everything?
Everything, all the way to the sensor, all the way to the edge.
Okay. What happens if there's model drift, Gaute?
So model drift is what happens when the world changes and your model doesn't, right? And so that requires a set of skill sets, formal skill sets in both mathematics and statistics that then can be used to mitigate model drift, right? And one of the reasons we are very excited about working with Corvalent is simply that working directly with the hardware, working with Corvalent, we can get to the actual source directly, down to the bare metal.
Right.
This allows us to do things like calibration, and it allows us to understand how well calibrated a sensor network or sensor train may actually be or may not be. And this is crucial for modern mathematical statistics if you want to get to accuracy and precision. Another reason why, coming back to my comment earlier, why off-the-shelf systems where you include a complete analytics solution for preventive maintenance, for example, rarely works in real life, simply because it failed to take into account the actual calibration of the sensor train, the bare metal components involved and how they work and talk together and so on and so forth. So we're very excited about working with Corvalent at the hardware level, from the edge and all the way in.
Fantastic.
Yeah.
So what would you say are the classical challenges in deploying custom AI and ML in the real world? I mean, if I'm an oil and gas executive, right, I want to know the benefits, I want to know the costs, but I also want to know what are the challenges that we face.
Yep. And I think primary cultural is one of the biggest barriers that
Can you explain that?
Yeah. Cultural at many levels of organization. So meaning starting with, for example, the process engineers, the field engineers, if you will, in oil and gas, typically come from 30, 40 years of classical engineering, meaning linear mathematics, linear approaches, isolated use cases from a mathematical perspective. An engineer working on a booster gas compressor will primarily be concerned with the booster gas compressor, and he will be a specialist on booster gas compressors. Now, to problem solve a complex recurring anomaly or problem with a compressor, it will require more than the current knowledge of the engineer that's assigned to the compressor. This is obvious. Otherwise, the problem would have been solved. So when we come in, we tend to meet cultural pushback from SMEs at the initial stages because there's tremendous confidence in current approaches.
I see.
And so I think cultural also translates to the middle management level, who tends to think of modern AI ML techniques as intrusive, potentially something that could cause rotation and labor divisions to change, right, within the organization, and push back on the sense that this may lead to automation that's not desirable or that's not wanted. And I think at the executive levels, we often see pushback based on the notion that custom will take too long or custom will not yield the results. And ironically, they turn around very often and they subscribe to multi-million-dollar off-the-shelf software packages that have proven not to deliver accuracy and precision for over 50 years. And so I think the cultural paradigm is very important here, very important.
That's really interesting. What are some of the use cases, Ed, in oil and gas that we can apply AI and ML to? And then same question to Gaute after Ed. Ed?
I think of probably 90% of the cases that we're seeing out there in terms of different segments in the industrial industry is that we see AI and ML actually play a huge role. And that's one of the reasons we're dealing with, IQumulus being one of our greatest partners, is to provide that entire turnkey solution in many, many ways. I think one of the biggest challenges we see in the industry is that customers that are about to implement IoT, in their whole process or in their machinery or in anything that they're trying to do. Well, first of all, for the whole purpose of implementing IoT, there's our three. Either you're trying to make more revenue, or you're trying to save millions of dollars, or you're basically trying to be concerned about safety and security. And that's when you stay out of trouble. So those are the only reasons you want to do this, that way you have the enormous ROI. But ML in artificial intelligence is pretty much going to be applied 90% of the cases when we see it.
Fantastic. Gaute, so what are some of the examples you are currently doing in oil and gas? Because I know that you have a focus on that, and it's one of your market segments. And petrochemical production, where custom AI and ML can make a difference.
Yep. So I think most of the viewers or listeners to this webinar will be familiar with more of the low-hanging fruits, if you will, in machine learning application. And by that, I refer to things like preventive maintenance, so vibration, rotation, temperature, flow, pressure, gas, all the classical monitoring techniques that
hydrogen sulfide in the product.
Sure.
Yeah.
So this is something that we've worked on and that we can't work on, but represent more of a traditional challenge where we can more or less guarantee results and improvements, typically in the 30 to 40% optimization range.
And how long would it take to implement a classic solution, but using AI and ML techniques? Is it years and years and years to deploy a model?
Not a model. I think typically we can get the results in 2 to 3 months, right? With a custom model, yes. So through an initial discovery and exploratory stage, we can get the results in 2 to 3 months. And then the question becomes, how do you scale this? And this is where a lot of corporations are hitting a wall currently.
Right.
They are able to drive it to a certain level of adoption. Let's say they have 2 or 3 pilots running in parallel for 6 to 9 months. Beyond that, 18 months later, most of those have either fizzled out due to lack of results, or they're simply not scalable because they were never designed as experiments to be scalable. And so I think
I've seen a lot of that actually in industry, yes.
It's very common. And so I think one of the things we bring to the process is a very rigid process that follows a user-centric approach, where we really and truly map out the actual unmet need of the end users, the SMEs, the stakeholders in the process at the analytics level. And that allows us to design experiments that we know ahead of time will be scalable. So in other words, the way to approach modern industrial machine learning goes through modularization. You have to start with 2 or 3 very scalable use cases that you can then naturally and organically scale over time. So we've seen examples where individual analytics cases can be scaled from 1 plant to 10 to 15, then to 50, 60, right? So maybe the initial modularization process and EDA or exploratory data analytics take 2 to 3 months. And then you roll this out and you can scale it more predictably over the next 2 to 3 years, with the costs coming down in the process as this becomes more and more commoditized from an internal perspective.
So the scaling, Ed, helps guarantee return on investment?
Absolutely. And the consistency actually helps that scalability, right?
Right.
So I think that's one of the biggest issues that we see in our market too. And when people are using multiple types of hardware and they're basically mix and match and do that kind of a situation, right? And I think that's really extremely important that people take a good look at that consistency of hardware throughout the whole entire infrastructure. To create that data integrity, I think that's one of the biggest issues. We see that in many situations. Obviously, artificial intelligence and machine learning, like Gaute is talking about, it's really applied to a lot of critical applications. But converting things to AI today, if you take a simple machine or you take a complex machine, it's going to create a critical application. And that's why it's so important that all these components that are very critical to have the highest integrity and highest quality. The other issue that I see in the entire thing is that a lot of the packages that you see out there from an IoT implementation, does not offer the flexibility of customization, or I can call it configuration.
Right.
When you're applying AI and ML, and it's one of the reasons IQumulus work with us too, it's because the ability to do that configuration of the system itself in terms of the software and the hardware, because no size fits all. It's not a no size fits all.
So you're proposing essentially the value proposition that you have is that you work with each individual customer and configure and customize a proven platform
to their specific application.
Their problems, their applications.
That's correct.
I'm with you.
And I think that you have to offer that, an enormous amount of flexibility there, on something that can be applied really easy. And that's the other thing too, designing a platform like we did to make sure that we offer a high level of customization and configuration that can be done, that it takes little time. So the time to market in this industry is obviously a really important thing.
Right.
But to get the right ROI and the whole implementation of IoT these days and in machine learning and all that, I think it does require a high level of flexibility from vendors that are going to help you get to that point.
And there was a point that you made earlier that you're a one-stop shop. That means you can get the sensors, you can get the edge computers, you can get the servers, you can get the software licenses from who? You?
Yeah,
from
our
shop
side.
around and go put this all together.
That's correct, and that's a big challenge as well. A lot of companies are not in this industry. They're not experts in finding the right edge or the right level of sensors and stuff like that. Yeah, you can find them, but when you take a company that is so focused that is providing all these building blocks all together in terms of compatibility, in terms to get everything from one-stop shop, don't have to qualify different vendors or going through a lot of exercise with a lot of vendors and having different failures and all that. It hinders the application development, but also hinders the success of the implementation.
Yep.
So I think that's one of the things that customers have to be sometimes very frustrated because they have to suddenly be not in the industry they're in, on the specific machinery they're building, an industrial process they're doing, or they're smart monitoring somehow. They have to actually focus on doing something that is not their competence. And that's why I think companies like Corvalent will come in, and IQumulus with the whole entire solution comes in and help them to do the full implementation. Right. And that's extremely important. I think no software, no solution would work reliably without the integrity, the data integrity, but also the communication scheme well put together and implemented inside of the organization. It's not a simple process, but the more complex it gets, sometimes the biggest the ROI, can be delivered.
That makes a lot of sense, actually. Yeah. As a reminder to the audience, we're starting to get lots of questions in. That's fantastic. Put them down in the chat box, and at the end of this little conversation, we'll address them. Gaute, where do you see digital twins in the industry, and what is that exactly? I mean, I've heard the term before. I think I know what it is, but I might not, right? Can you explain that?
Yeah, it just reminds me of a recent visit to a big offshore technology conference, OTC, in Houston, just as of last week, where again, you see digital twin used in maybe 20, 30 different ways, right, across the floor in one day. And so I don't think there's one definition of what digital twin actually is as of 2024. It remains an idea, almost like AI as a philosophical construct, right? Digital twin is this idea that we can have a virtual version of reality, whether that's visual, it's numerical, that depends on the context and who you ask. But I think where I see it right now in the industry, just in terms of kind of describing the situation, again, walking the floor at OTC a week ago, you see large incumbents still providing very basic simulations, right? Very often of a very discrete scenario. So you're on a ship bridge and you're holding a joystick and you're trying to maneuver the vessel, right? That's a simulation, but it's also, to some respect, a classic digital twin experience.
So you don't hit a bridge.
So you don't hit a bridge.
Ed, was Corvalent at the same conference as well?
Yes, we're exhibiting at the conference, the Offshore Technology Conference. We have been doing that for about 15, 20 years now. It is obviously, the oil and gas is a pretty large portion of our business today, and we're very much in the energy industry, for quite a bit of time. And OTC was really good this year. It was a fantastic show.
I heard it was very well attended also as well. It seems that we're over this COVID fear of
That's
being
right.
around each other a lot. So I got to ask you something. Do you see AI and ML being applicable to upstream, midstream, downstream? Do you see that there's more opportunity in one over the other, or?
That's a very good question. I do think that upstream is probably where there's most work left to be done, to be honest. I think the closer you get to the source, whether it's source of oil down in the bore well, right, 23,000 feet below, or if it's at the platform level, we are looking at a world that is largely aging, right, in terms of sensors and equipment. There's a lot of pneumatics. There's a lot of analog meters, right? There's a lot of sensor, or I would say a lot of these installations are sensor poor, right? They're not properly outfitted.
Right.
A lot of virtual metering going on that's not accurate by any stretch, right? So So there's a lot of work that can be done in terms of optimization the further upstream you go. And I think also that the further upstream you go, there's a lot of still remnants of the linear engineering culture, as we call it, where it's a very mechanical analog approach. Spade is a spade, and whether something could be correlated or not is not really of concern, right? Because what I concern myself with as a senior process engineer for subsea are these 4 parameters, right?
And is this different from if you're working the Marcellus or the Eagle Ford, or you're up in
or offshore,
the Dakotas,
offshore, yeah.
or is it kind of the same set of problems that you might see?
Conceptually, the same set of problems keep occurring, right?
But the devil's in the details, right?
The devil's always in the detail. Yeah,
I see.
That's very well said.
And that's why you have to customize.
Absolutely, absolutely.
Right. It makes sense. So where do you see digital twins in 10 years?
I think digital twin is moving in a good direction, meaning that we are maturing the approach. At IQ, we're very concerned with being part of shaping that in terms of building prototypes early that are very, very forward-leaning from a technology perspective. By that I mean we are already working on very advanced 3D visualizations that are built bottom-up for physics-informed problems. So in other words, we're more concerned with the science and accurately reflecting the science behind the problem. We're also more concerned with capturing the actual unmet need of the SME or the subject matter expert, and then building out a very, I would say, hyper-realistic realization of that, so that a digital twin can actually fulfill its original promise of being useful and practical. Right?
I'm going to coin a term here. I don't know if this is in the industry or not, but digital fidelity. And measuring how accurate the digital twin is to the real world. Is that a concern? Is that a useful concept?
Well, you basically you encapsulated the essence of the problem, right? Yeah.
So why did you want to partner with IQumulus, Ed? And I'll ask you the same question. Why did you want to partner with Corvalent?
Yeah. Well, IQumulus brings, it's basically the icing on the cake, for us, because obviously a lot of customers have different challenges in terms of implementation, not only of the IoT, monitoring and tracking and control, but they also have the challenge of the machine learning, and they have the challenge of creating algorithms and things of that nature to actually, for a complete implementation, right?
Essentially, the math.
That's right, the math, and also to get the biggest ROI. I think that that is extremely important, which, is one of the things that I wanted to mention too. We're offering customers a 1-hour consulting session with both of our engineering groups, IQumulus and Corvalent together, to talk to customers about different solutions and so forth.
So anybody on this webinar that wants a free hour of consulting, no obligations, no contracts, confidential, you're offering that, folks?
Yeah, absolutely.
Take advantage of that. If you're interested, put your name and email address in an email and send that to Corvalent or IQumulus, and these guys can and their staff, I would assume, can help you solve some real world problems. Speaking of which, can you deal with analog devices also as well? I mean, not everything out in the field is, as Gaute said, is digital, right? There's still a lot of analog stuff out there.
Correct. Yeah, we have seen applications that still have analog devices, and I wouldn't say majority of them, but I would say a large percentage of it we should be able to deal with.
Right.
And that's the way we design, this whole infrastructure, this whole platform was to actually deal with analog and digital devices. And we've seen too much out there, just like he was mentioning, a lot of the infrastructure based on, old technology and sensors and so forth. There'll obviously be situations where they want to get better performance, better data, and that was going to be an upgrade to a digital, to a digital device. But if there must have analog devices, we always find a way.
Fantastic. And then I'll ask the question of Gaute. Why does IQumulus want to work with Corvalent?
Well, it's easy to answer for me. We have been considering and looking for a hardware type partner and software partner for quite a while. And as you can imagine, we are extremely picky when it comes to the data generation side and the hardware side. So when we first were introduced and we realized that this is a trusted legacy provider of industrial computing equipment, that in itself, a 30-year history, kind of the Cadillac of custom OEM. We realized that this was potentially a very good fit, and it has turned out to be, and we're very excited about it. So I think that comes back to the integrity that Ed has referenced several times. Data integrity starts with the sensor, right? It starts with the integrity of the equipment.
Absolutely.
Yeah.
And between you've got over 30 years of experience in AI and ML, and you have over 30 years in computer engineering and hardware and software.
Yeah.
Combined, I guess.
Yeah, you're talking about it's a combined, it's not an average. It's definitely a combined experience. You know, it's every conversation that we have, every application that we have worked together, has also shown that 60-year experience in the industry, right? And that's it, and that's enormous. I'll tell you, I see some of the challenges that we resolve out there between our CTO and Gaute, and all the product management on the IoT side, and project management that we do, all the software engineers. I mean, it is an enormous amount of knowledge, and competence that we see among ourselves. And then, getting together with customers that are very focused on their vertical, very focused on their business, experts on their business. This is a monster. This is absolutely like one of the funnest things that you can do in life. It's resolve some of the biggest issues.
So you guys really enjoy building the future.
Oh,
what you're saying.
Absolutely.
That motivates me also as well. And I like making companies safer. I like to make companies generate a higher return on investment. I like to save money. And I think that IoT, and especially industrial IoT, will do that. Yep. So that's good. I want to thank you, Ed and Gaute, for that really informative and fun conversation. And we'll now open it up to some questions.
So here's an interesting question. This is for Ed. Do you see the enormous amount of data that is produced at the edge being a problem? I know that folks want to store all this information in the cloud, but what is the role of edge computing in these kinds of scenarios in oil and gas?
Well, obviously, the whole role of edge computers really rely on the reliability of that edge, and also the way the software is designed. Like our platform, works pretty much on the edge and in the cloud. So there's, things that you can do at the edge. For example, one of the things that if you lose connection to the internet, for example, and you basically are gathering data, you're processing data, everything at the edge. We have actually designed something in our platform that the minute or the second that you actually get connection back again, we will do a synchronization utility that basically goes back to the cloud, and it basically synchronizes all the data that you have to actually do, right? So that's one of the things that is so important about the edge and how it's designed, the whole process, how it's designed. Many platforms out there does not do that. You really rely on the edge just to basically do some processing, but the synchronization is absolutely most important thing. We spend a lot of time in development to do that.
So what you're saying is that it also solves latency problems. I mean, when you need real-time analytics and real-time analysis, and you're using AI and ML, you need very fast response times, right?
That's correct. Yeah, you definitely need that. And in some applications you cannot get to real time, but in most cases, if you have the right communication scheme, and you're using the latest and greatest communication, network, you should be able to do real time with a platform like ours, right?
So Corvalent and IQumulus, they can work both onshore and offshore?
How
onshore
do you
and
get the
offshore.
information back from offshore?
From offshore, you have different ways to do this, right? I mean, most people use satellite. That's one way for you to do,
Right.
and it's basically one of the greatly reliable things to do these days. With all the satellite infrastructure that exists out there, that's something that we have seen customers do, in many, many, many ways. And
So it's
go ahead.
sorry, please continue.
Yeah, no, go ahead. Go ahead. You're going to mention
So
something.
it's almost like it's satellite as a service, right? You can just sign up with satellite providers and there's your comlink. What would what's the role in 5G and IoT?
Well, it's definitely, great for backhaul for long distances, right? I think that's a really, really important. I mean, you would use industrial protocols such as wireless HART. It's one way to do it. Sensor might transmit wirelessly, or using industrial Ethernet. Depends on the application and the environment, obviously. I mean, then 5G can shoot that information to the cloud or the premise server, right? On the premise servers, right? I think that's
Right.
an interesting way to do this, right?
I guess what I'm getting at is your communication protocol agnostic, right? You really don't
That's correct.
care, and you can work with any customer on that. Gaute is an expert in AI and ML. His company's been around for over 30 years. Was
Right.
there was there something that was especially attractive to working with him, do you think?
Well, obviously, when you get to situations where artificial intelligence applies, you have to be very focused on people that actually do that and do that only, right? And especially with the amount of experiences IQumulus have in that business. Over 30 years doing these things, 14 in this company that he's done, but he's been 30 years in doing industrial process intelligence, and that's extremely important in order to do that. I mean, that's not necessarily the focus of Corvalent, because there's just so many segments and different critical applications in different segments that we decide to be on a data integrity kind of a business and make sure that we provide that data integrity not only from a hardware perspective, but from a software perspective, to make sure that there is an integral way to deliver that data, right?
Okay. One last question, if I might, Ed. Would that be okay?
Yeah, absolutely. If you can pull one up.
Okay. So just to wrap things up, in general, do you perceive that customer? So one thing about your platform that I've noticed, and everyone remarks upon, is how great the user interface is. Right? I mean,
Right.
you spend a lot of time on that,
Right.
and it's intuitive and easy to use. But a lot of customers have their own IoT platforms also as well. Can the information be exported from your platform into theirs easily?
Yes, it can. There's different ways to do this. Obviously, we usually create an instance for customers to work on, that they can develop their own, sensor gathering, data information and so forth.
Uh-huh.
There's lots of ways to do this, but we also create APIs, to work with customers, and that's the level of flexibility that we provide. When we design this, platform, we design on a total idea of starting from taking a map, going to a location, going to the asset, going to the devices, and reading it all. And we included all kinds of different things, from service tickets to rules engine to to security concerns in communication schemes and alert systems and so forth. So it's a total enterprise situation where you actually connect to to different ERP systems if you want to gather data from financial data if you want to, and bring all data into a single pane of glass. But also enormous flexibility, because we design with all industrial protocols in mind. All the industrial adapters are included on this application, on this platform. So basically we can work with any application that basically has different kind of protocols. So we're agnostic to the protocols as well, and agnostic the way this is actually, the data is actually ingested. So it's created that way on purpose.
I lied, Ed. I actually have one more question. How can folks get in touch with you if they're interested for more information?
Well, obviously, you can go to our website and go to www.corvalent.com. You can go there and connect with us, but you can always contact me directly at ed.trevis@corvalent.com. And you basically call our toll-free number as well, 888. You can call that direct number to us, 776-7896. And talk to us directly. We have a group of engineers. We have a group of technical salespeople that can talk to you. But like I said in the beginning, we can offer, our 1 hour, or it doesn't have to be exactly 1 hour, but some consultation with our engineers and IQumulus engineers too. We love to hear different applications. I mean, it's always exciting to us because we're in so many different segments. We're in 12 different segments of the industry, and it's so kind of cool to go from semiconductor equipment to oil and gas to medical applications to defense applications, and learn so much about different applications. And obviously, being an American company, we keep all the intellectual property and we sign NDAs and make sure that we keep your project in mind in terms of confidentiality, right?
I have a question for Gaute. How does IQumulus work with Corvalent? How do you collaborate best?
We follow a very, very rigorous process that we apply to all of our projects. So when we work with Corvalent, it's no different than from our own projects, where we focus on mapping the actual unmet need or the requirements of the client to make sure that we do not purchase, sell, install, deploy, develop solutions that does not ultimately meet the end user requirements. And so the process is one where we typically follow the user experience research path first, and we do that whether it's hardware or firmware, software, analytics, whatever it may be. And then we gradually unpack the data mapping, data sourcing, data engineering, data science aspects of it. And then we get into, if need be, applications built to specification on the front end with software front end and so on and so forth. So this is how we work with Corvalent, and we're very excited about the ability to actually custom or build bespoke systems to high specification from the hardware up following this process. That's what we're very excited about.
So here's an interesting question from somebody from Rochester, New York. Is there a continuum of data analytic methods? I mean, how do you know when machine learning is the appropriate tool to use rather than, say, classical statistics?
Great question. And the academic question or answer would be, when you have a nonlinear multivariate problem. That's usually where modern mathematical statistics are a good fit. And we have methods and processes for evaluating the problem space and opportunity space. And we do that by statistical research, first of all. So we typically start with classical statistics. And then once we exhaust some of those methods, we move into modern mathematical statistics.
Fantastic. Somebody mentioned that they were on your website and they wanted to know what the modern transformation paradigm is. Can you explain that?
Yeah, the modern transformation paradigm is something we coined a few years ago because we think it's extremely important to highlight that the classical transformation paradigm has more or less failed over the last 50 years, which means that in classical terms, you would take the objectives of the business owner and the technology owner, and you would specify a solution top down, and you'd say, we're done. Now, in reality, we have all seen examples of those projects ending up without the accuracy and precision we expected and without the return on capital that we wanted. So a few years ago, we came to terms with the fact that we have to come bottom up. And this comes back to the process and the rigor that I mentioned earlier, where we believe in starting with the end user. So that might be a senior process engineer, a chemical engineer. It may be someone that knows the domain inside out. Let's start there. Let's understand the real world before we start applying new technology to the problem.
Very interesting. And it seems obvious, but I guess it's not in the modern world, right? It's a lot of top-down initiatives, but you got to go bottom up in order to get the kinds of data and insights.
Absolutely. I think that you cannot really call it a scientific process or a real process without considering the real world, right? And in the real world, you have real people doing real things and managing real processes every day. And if you don't understand those, you're not going to discover the problem or the depth of the problem. You're not going to solve it. So I think for us, it really is about bottom up, as you say. And I think the top-down approach has survived because of corporate executives becoming very accustomed to and comfortable with acquiring software solutions from incumbent software providers. So it becomes more of a budget management process, right? OpEx, CapEx, and so forth, which is understandable. However, in the real world, when you get out in the field, this approach tends to be rather
suboptimal, perhaps?
Yeah, suboptimal. I'm trying to find a nice word to use that doesn't offend anyone.
That's why I picked suboptimal. Very good. So this is a more straightforward question than that. What kinds of data can help with predictive and preventative maintenance? That's a key application in IoT, and especially in oil and gas. So what kinds of data can help with that?
So the classical use cases for predictive and preventive maintenance typically deal with rotating equipment, right, and vibration. So sensors that allow us to accurately capture rotation, vibration, but also temperature, pressure can be a very great value for predictive and preventive algorithmic development. We also have, of course, flow and more, unique aspects or dimensions of flow and flow measurement, and sensors can be very helpful in predictive as part of larger assemblies or more complex assemblies. And then also gas monitoring should also be part of it. Steam monitoring is something that's underestimated and appreciated. So there's a wide range, I would say, but any of the classic sensors are great for predictive work.
That's an absolutely fabulous answer, and it also implies that you need to get the data from different sources, and having that expertise on how to do that's important also as well. Specialization. What is time series data?
So at its simplest manifestation, time series data is the data produced by a sensor that puts a date and a timestamp on a process. And that date and timestamp can be produced every few milliseconds, every second, every minute, so on and so forth, at different temporal resolutions. And so what we specialize in and what we bring to the collaboration with Corvalent more scientifically is over 30 years of specialization in the area of natural time series or organic time series analysis. And that's a deep field of study in and of itself.
I'm intrigued and I'm worried. A lot of us are studying artificial intelligence, machine learning. We want to get the skills necessary in order to be effective at our jobs. What are some of the roles of AI and ML from an end user standpoint? What are the things that machines can't do that the engineer can do?
Yeah, that's a phenomenal question these days. I think what we see who work in physical processes in the physical world, in the real world, is that the most valuable use cases for the end user when it comes to machine learning techniques in particular deal with those scenarios that have so many features, so many inputs, if you will, to a model, right? And so much depth in terms of the data. So the frequency of the sampling and the temporal period over which that sampling happens could be 10 years, right? We're dealing with gigabytes or petabytes of data sometimes. And so at that point, the real value to the end user becomes machine learning techniques that are capable of extracting correlations that are hidden to the normal human observer, right? Where it's simply an inhuman task to detect patterns within data of this size. And so, and complexity. And so I think that's where machine learning techniques, specifically on the natural time series side, can be phenomenal tools for discovering hidden patterns that can unlock economic value, that can unlock operational value, and so on and so forth.
Right. Well, I want to thank you, Ed, and I want to thank you, Gaute, also as well, for a really insightful and interesting webinar. Folks, if you have any questions, get in touch with Corvalent, and they will reach out to IQumulus, and they can solve your problems. For Ed Trevis, for Gaute Solaas, for myself, Alan Weiss, and for everybody on the webinar, I want to thank you for attending. Have a terrific day. Have a high performance day. Bye-bye.